We're going to work through number 21 to 24. So let's get right into it. Number 21, we want to graph y equals tangent of theta plus pi over 3. We know when something's added to theta that is a phase shift. So this is going to be moved left pi over 3. We're dealing with tangent here. There's nothing multiplied here in front of theta, so it's just the normal period, and tangent has a normal period of pi. Amplitude, that would be if something's multiplied here. Tangent actually doesn't have an amplitude, makes it steeper if something's there, but nothing to be concerned with there. And vertical shift, there's nothing added out here, so that is also 0. So what we'll do here is we'll draw our x-axis. We're not going to put the y-axis in yet because we have a phase shift. So we're going to put our starting point. We're going left pi over 3. So negative pi over 3 is our starting point. We add the period to that. So we're going to put in kind of an ending spot here. So negative pi over 3 plus pi, which we can get a common denominator. So negative pi over 3 plus 3 pi over 3 is 2 pi over 3. That is our ending point. And then we want halfway in between, which we know will be a vertical asymptote. And we can add those together and divide by 2 to find that middle point there. So negative pi over 3 plus 2 pi over 3 divided by 2. And sometimes, actually, we didn't work with the pi over 3. Sorry, with the denominator of 3, but I put it in there this time. So we have pi over 3 over 2. We know that dividing is the same as multiplying by the reciprocal, so times 1/2. So that middle point there where the vertical asymptote is pi over 6. I didn't leave a lot of room here. Maybe I'll go over here a little bit more, put in another vertical asymptote, and we know at our starting point it goes through 0, at our ending point it goes through 0. We can put another vertical asymptote here. I didn't label either of those vertical asymptotes. We could work through that, but we don't need to right now. And so here is our graph of tangent. Goes through those zeros, gets closer and closer to the vertical asymptotes. Number 22, y equals cosine of 3 theta times pi over 4. So we see we have phase shift is left pi over 4. Period has to do with this guy right here. So we take our normal period of cosine, which is 2 pi, divided by that number there, so divided by 3. Amplitude is what's out front multiplied by cosine, which is still just 1. And vertical shift is 0. And so when we graph this, again, this has a phase shift, so we're not going to put a y-axis in there yet. So we start at negative pi over 4. Our period is 2 pi over 3, so a much smaller period. So we'll put our endpoint here. So negative pi over 4. And we want to add our period to find the end point there, to find out where this ending is. In order to do that, we need a common denominator. And so let's multiply this by 3 over 3. Multiply this by 4 over 4. So really we're doing negative 3 pi over 12 plus 8 pi over 12. Puts us at 5 pi over 12. All right, so it's supposed to be a 5. It kind of, there we go, 5 pi over 12. All right. Well, this is cosine, so we want to split this into 4 equal parts. We've been doing one method. I'm going to show us another method we can do here to help us find these points. And at times, I actually think this is a little bit easier, especially with this setup with a 4ths and a 12ths. So what we're going to do is this period is 2 pi over 3, and we want to split 2 pi over 3 into 4ths. So I'm going to take that 2 pi over 3, and I'm going to multiply it by a 4th, which is 2 pi over 12, which is 1/6 pi. I'm going to leave it like that because what this is saying, each quarter I'm going to go up, and I'll erase this in a second here, but I'm going to add 2 pi over 12 to get to this point, and then add another 2 pi over 12, add another 2 pi over 12, and add another 2 pi over 12. So that can get me those 4 points there. So let's get rid of those. So we're going to take this negative pi over 4 and add 2 pi over 12. And so this, we need to get a common denominator. So this is really negative 3 pi over 12 plus 2 pi over 12. And I'm writing this all out, but this is going to be a little bit easier once we get started here. So this is going to be negative 1 pi over 12. So this spot is negative pi over 12. And then we're going to add 2 pi over 12 to that. Well, adding 2 pi over 12 to that will give me, or us, pi over 12. Adding 2 pi over 12 to that will give us 3 pi over 12, which does reduce. I'm going to leave it like that for now. So that's maybe sometimes an easier way to find those 4 points is to figure out your period and then multiply that by a quarter. So at our period, here's our period. We multiplied it by a quarter to show that each one of those sections there, you can go up 2 pi over 12. And we could keep doing that to find some of our other points. We could add 2 pi over 12 to get to this spot, which would give us 7 pi over 12, 9 pi over 12, 11 pi over 12. So hopefully you get the point there. All right, so here we go with cosine. Now that we have this here, this is pretty easy for us to find our y-axis. It's halfway between negative pi over 12 and pi over 12. Our amplitude is just 1, so we can go up to 1 and down to negative 1. I'm going to go ahead and put some guidelines here so we can see where cosine is going to go. And so remember, this negative pi over 4 was our starting spot. Cosine starts up and then down. Now our y-axis is just there. That's not one of our special points in there. So down to 0, down to negative 1, back up to 0, back to 1. And we can continue that pattern as we work our way through here. And then we can graph. And there is the graph of cosine of 3 times theta plus pi over 4, probably one of our trickier ones. All right, number 23. Phase shift is left pi over 6. Period has to do with this. It's our normal period of sine, which is 2 pi divided by 4. So this is pi over 2. Amplitude is 3, and there's no vertical shift. I'll draw the x-axis here, but I'm not going to put the y-axis in yet. So our starting point here is at negative pi over 6. Period is half pi. So I'm going to take negative pi over 6 plus pi over 2 will give me this ending spot here. So we're going to multiply this by 3 over 3. So we have negative pi over 6 plus 3 pi over 6 is 2 pi over 6. Now I know that does reduce, but I'm going to go ahead and leave it like this for now. All right, let's get into finding our other spots here. I'm going to use the same method I used for 22. I feel like this method works best when we do have a phase shift and a change in period. We want to take our normal period, not our normal period, our period, and we want to multiply that by 1/4, because that's going to tell us how much space is from our start spot to our first quarter, and then we're just going to keep adding that. So we're going to take pi over 2 times a quarter, gives us pi over 8, which is fun because we're going to have to add pi over 8 to each of these, and we have denominators of 6 already. And so what we can do is think about what's the common denominator of 6 and 8. That is 24. And so we're going to take this negative pi over 6 plus pi over 8, get our common denominator, which is 24. So this needs a 3 over 3, and this one needs a 4 over 4. So this turns out to be negative 4 pi over 24 plus 3 pi over 24 gives us negative pi over 24. And that's usually the harder one. Once we have that, it's not as bad. So negative pi over 24. And we're going to add 3 pi over 24 again. So negative pi over 24 plus 3 pi over 24, because that's our quarter, is 2 pi over 24, which does reduce, but I'm going to leave it like this for adding. And then we're going to add 3 pi over 24 again, which gives us 5 pi over 24. And we could do a check here. We could add 3 pi over 24 again, which would give us 8 pi over 24, which reduces to 1/3, as does this. So that's it's good that they're the same number. I'm going to go ahead and erase this, because that's kind of in our way. All right, so that actually was the difficult part there. We can see our y-axis would be somewhere about right here. That wasn't very good. That probably should be a tad to the left. Our amplitude is 3. So 1, 2, 3, -1, -2, -3. I'm going to put my guidelines in there. And this is sine. So sine, here's our starting point here. Sine starts at 0. I'm going to erase this little thing here. And then we go up to 3. We're not using the y-axis. That wasn't one of our special points. Down to 0, down to -3, back up to 0. And then that pattern continues And then we can sketch our sine graph. Oh, sorry about that. All right, there it is. All right, moving to 24. 24 actually might be a little simpler. I know it's cosecant, but it does not have a phase shift, so that usually makes it a little bit easier. So no phase shift. So before we do that, remember first, let's do this. We'll put this in blue. First, we're going to graph y equals 3 sine, because sine is the reciprocal of cosecant of theta over 3. So phase shift is 0. Period. Normal period of sine is 2 pi divided by 1/3, which is really 2 pi times the reciprocal of 1/3, which is 6 pi. Amplitude is 3. Actually, we're looking at this one. Amplitude is 3. Vertical shift is 0. So there was no phase shift. That's why I have the y-axis in here already. I'm actually going to take this whole thing and shift it down since I had so much writing on the one above it. Actually, another thing I'm going to do is going to stretch this out a little bit. All right, so no phase shift. So we can start right there at 0. Again, this is graphing sine. So then my endpoint is 6 pi. Well, 6 pi is pretty far away, and since I can, I'm going to go ahead and drag this out. I know you guys can't go off your sheet of paper, but 6 pi is pretty far, so I do want to show that this was spread out. All right, so here was 0. 6 pi is the end of our first cycle. Oh, this is a lot easier. Splitting that in half between 0 and 6 pi is 3 pi. Between 0 and 3 is 1.5 pi. And then 4.5 pi. I'll go back to blue. Well, maybe not yet. So our amplitude is 3. 1, 2, 3. -1, -2, -3. I'll go ahead and put those guidelines in there. You don't have to put the guidelines. They can just be helpful. So I'm going to graph sine. So sine starts at 0, goes up to the top, which is 3, back down to 0, in this case down to -3, back up to 0, and we'll put one more thing here that's back up to 3. I'm going to do a dashed graph here because this really isn't my graph. This is just to help me graph cosecant. And as we recall, well, actually, now let's switch over. Let's switch over to black. So now we're going to graph this. So wherever this hit the x-axis, we're going to have a vertical asymptote. And then we can graph. So I'm going to come over here. I'm almost running into number 26 here, but let's graph this. And there is the sketch of y equals 3 cosecant of theta over 3.